Hello, everybody, and thank you for joining. So the idea of this webinar is to share with you some of the lessons learned, my lessons learned of mixing the theory of constraints with Agile and Lean ideas. So we have 30 minutes, and then you will have 50 minutes to ask your questions. You can also note down your questions in the tool, so don't hesitate to write it down. And at the end of the presentation, I will do my best to answer it. If there are too many, we will spend time to answer you via email. And if you want to access the slides and the document I'm going to share with you, you will be able to download it directly on our website. Okay, so I'm going to do the full presentation. And I wanted to do that because even if my background is mostly in manufacturing or industrial projects, I had the opportunity to work with many companies that were trying to implement Agile, that had started to implement Agile, or that were already fully Agile. And they were interested in going further and using the theory of constraints to improve their project delivery. And so I learned a few things based on this experience, and I wanted to share it with you. So my background, as I said, is mostly with doing consulting, transformation projects with industrial companies in new product development, engineering to order, CapEx projects, maintenance, repair, and overall, but also some IT projects like ERPs, implementation, CRMs, and this kind of stuff. I'm lucky because I can work with companies, international companies in France, but also in Spain, the US, in Poland, Mexico, United Kingdom, Czech Republic, well, many countries. And I do that in aerospace, oil and gas, medical devices, software development. So there are a few case studies that I want to share with you based on Marris Consulting experience and my experience. Half of our assignments are about helping companies increase the number of projects they finish on time each year, and 50% is about helping factories to improve their performance. And to do that, you may know that we use the theory of constraints, critical chain, lean, and also a bit of Agile. So let's start. As you see, most of our customers are industrial companies, but I will show you some case studies of pure software companies. Well, as I said, I stumbled upon a few companies that use Agile, and usually when we say use Agile, the true Agilist, they say, well, okay, you don't use Agile, you are Agile, or you are going the Agile way, you respect the Agile principles. But in companies, doing Agile means that usually you have product owners, Scrum Masters, you were trained and certified. You have implemented Agile processes like Agile ceremonies, daily stand-ups, sprints, retrospectives. You manage backlogs of features, and you do all that with specific tools like Jira or Azure DevOps. But in fact, what we want to do is to support the Agile principles, and we can count, let's say, 12 Agile principles. They are about being more customer-centric, so improving the collaboration with customers to deliver value to them as frequently as possible, and to be flexible, so to respond to change. This implies that you're able to improve the collaboration between the teams. So you want to improve the interactions between individuals in small teams. And there is a strong focus on quality. So you want to iterate fast, to learn from trials and errors. And to do that, you need to have a strong testing system of your software. You want to simplify work, so you don't want to do what you should not be doing. And these imply also that you don't overburden the teams, so that you control your working process. I will not list and explain all the Agile principles, but what is clear to me is that these principles originated in the manufacturing and at Toyota, so what is known as Lean or the Toyota Production System. And there are many similarities between all these 12 principles, and Lean principles or Lean pillars. The two Lean pillars are just-in-time and JIDOKA, or right first time, strong focus on quality. You see almost the same ideas in Agile, where you want to pool work based on customer demand. You don't want to overproduce. You want small iterations, small batch of work that you can quickly deliver to the customer to show them value. You want strong collaboration between business and technical people, developers, engineers. This implies that managers spend time on the shop floor, working with the technical people, understanding technical constraints. And in Lean, this is what we would call Genshi, Genbutsu, or Gemba. And then there's also a strong focus on people, respect for people, helping them do their best, be proud of their work, understand their work, and master the processes. To improve collaboration, there is nothing best than visual management. So being able to discuss facts and to show it, to share it on visual tools. Continuous improvement with Kaizen and Hansei, etc. And in Lean, we also have a strong focus on limiting working process, so to remove overburden and to enable the teams to focus on the right topics. So everything is great. These principles are great in theory, but when you want to implement it, it's a bit more difficult. And the question is usually where to start. Or if you have already started, you may have noticed a few improvements, but if you want to go further, usually you get stuck and you don't know where to insist. So I would like to help you with that, thanks to the theory of constraints. Okay. If we visit an organization, and as consultants, that's what we are paid to do, to help different companies. And in project environments, what is usually striking, or what you notice first, is that when you talk to different teams, they have different priorities. So they work on different topics, the working process is high, and the complaints are almost always the same. So the customers are not satisfied, you deliver late, requirements are changing, it's difficult, it's quite hectic. Business and developers work in silos, there's a lack of collaboration, of communication. Many problems are always the same, even if the product or the industry is totally different. I would like to give you an example of some diagnostics that we did. So we do 2-day diagnostics and we visit companies. And here I visited a company, and to be more precise, I visited an R&D department. This is an industrial company. They do special machinery. And the first thing that I noticed was that they had a lot of projects. Their main problem was that they wanted to innovate faster, and they had not launched a new product for quite a long time. They had a reputation for innovation, being innovative, but they were stuck. And they had implemented Agile in some of their teams. So the electronics and the software engineers had implemented Scrum, some Agile routines, tools to handle their work, to do visual management, but still the R&D department was blocked and was not delivering new projects as expected by the market and by marketing and the rest of the company. So the first step was to look at the big picture and at the list of projects that they had. And we found that they had 30 projects approximately, but over the last 3 years, they had launched only 10 innovations. So approximately what they did was 3 projects finished per year. And if you compare it with the 30 projects on hand, started but not finished, this means that on average, they took 10 years to finish one innovation, to ship one innovation. And this observation was striking. So they realized that really they were blocked. And even with a bit of agile here, a bit of agile there, a lot of discussions and pressure from management, from marketing, if they were to continue with the same methods, if they were to continue at the same pace, it would take 10 years to ship these 30 projects. So this was like an epiphany, and I will talk about it later on, but they realized that something had to change. So before talking about all the agile routines and tools, etc., the advice or what I usually do is to consider 3 layers in project organizations. The first one is project portfolio. So just look at the list of projects and the resource pools. So what teams are working on this list of projects. Then you can zoom in and look at each individual project and discuss the tasks, the dependencies, who does what, and well, the details. And you can even zoom in more and go discuss with the teams, understand their problems, what tasks are blocked, do they have visibility over their work, do they have the right experts, the right skills, etc. So we can zoom in or zoom out, but basically project organizations are made of projects. Inside projects, you have tasks, and the tasks are done by teams on a daily basis. And the temptation or the usual way of doing things to improve the performance of the whole organization is to ask everybody to do their job better. So you go and ask the teams to do better using Agile, using Lean, using tools, using digitalization, whatever you want to increase local performance. But maybe we should start at the top and look at the list of projects to make sure that what we are asking people to do makes sense. So before going into the details, just take a step back. And that's exactly what the company that I mentioned did, looking at their portfolio of projects, and used some of the CRF constraints rules of flow. So the first rule of flow of the CRF constraints is that you have to triage your project, so to clean up your R&D portfolio. Many projects were on hold, were blocked for a long time. Priorities were not the same for the engineers or for marketing or for operations. So just gather the main decision makers and ensure that they are able to agree on what the priorities are. And because they had way too much in their pipeline, they had to decide on what to freeze, what projects to definitely put on hold, or put on hold until you have capacity to absorb this load. This is a whip control mechanism, similar to pull or to any other mechanism that control the working process based on the availability of your teams. Because you don't want to overburden them. You want some slack to absorb uncertainty, to absorb problems, and to make sure that you focus on what matters. When you do that, it's also much easier to synchronize people, but still some complex projects entail or have a lot of tasks and dependencies that you have to take into account. So we also proposed to use critical chain to map these dependencies. And one of the challenges was to get more engineers to work on one project. Instead of having a lot of people spread on many initiatives, help people to collaborate on the same topics on a weekly basis to get things done, and then continue with the project until it's finished. So here I have mentioned 4 rules that I will explain further with other examples. Triage, whip control, synchronization, and dosage. So what about the theory of constraints? Basically, we can summarize it like that. The theory of constraints is about addressing the fact that you do not distribute work equitably in your organization. It's impossible to have the same amount of work everywhere, to balance the load everywhere, especially in projects. Because of uncertainty, because of change requirements, because of all the things that you have to react to. So the theory of constraints is very relevant in this kind of environment. And it states that because the load and the capacities are not balanced, one of these teams, one of these resources has less capacity than the others and limit the output of the whole organization. You can have a few bottlenecks, okay, but not every team, not every person is a bottleneck. And a bottleneck is different from just a problem. A bottleneck is this team that limits the output. You can see that if the water here on the drawing is work and the tanks are the teams, for example, it doesn't increase the output to improve each and every tank, each and every pipe. First, you have to focus on your constraints, on your bottlenecks. And to do that, you need to identify it. And that's where agile practices can be great, provided that you implement it on a full work stream, end to end. Not just one team, but several teams to be able to identify the bottlenecks, for example, with Kanban boards. Once you have identified the constraint, you have a chance to improve it, to help it. And that's where you realize that there's a lot of waste. That's where lean is useful, because you acknowledge the fact that you're not 100% efficient. There are many opportunities to improve. But to improve, you need the support of the rest of the organization. If the rest of the organization, for example, marketing, continues to push a lot of initiatives without taking into account the limits of the team, the limiting team, it will be a mess. Once you do that, synchronize the rest of the organization and help the bottlenecks. Usually you find another bottleneck and you go on. If you want to know more about that, The Goal is a great book, but it's about manufacturing environment. There's another book, which is the Phoenix Project, which is great and which deals with these ideas. The theory of constraints is also about taking into account dependencies and uncertainty. And in the 90s, Goldratt wrote a book about improving project management with what he called critical chain. The idea is that if you want to shorten the lead times, you need to understand the dependencies between the activities and the limits of your resources. So you want to take into account your constraints, resource constraints. And you don't want to do just waterfall. You don't want to ask for precise estimates and consider that once it's planned, you just have to execute. You want to have slack and flexibility, but you don't want to waste this flexibility. So the idea, and if you want to know more, you can look at all our other videos on the topic, but you can just plan with very ambitious timelines, but manage a big buffer at the end of the project to remain flexible and to adapt to changes. The benefits compared to traditional Agile is that you map the main dependencies, and it enables to plan the features or to plan the chunks, the small chunks of work easily. Now, let's talk about the latest development of the theory of constraints to improve project delivery. There are two books that have just been published about mastering flow and the rules of flow. So I've mentioned four of these rules, but I will list them here and explain with some examples. These rules enable to support in agile implementation by helping you focus on what truly matters and prioritizing the agile components that you want to implement in the right sequence. So first, triage your projects. So make sure that the new initiative, new products that you want to develop, make sure that the customers that you address, etc., are really making sense for your organization. Then control the working process. Do not push work as if you had infinite capacity. Make sure that you have flexible teams and people, so pool resources. Enforce full kits. So don't start if you don't have a clear definition of ready and definition of done. Make sure that you have all the required items to start. Increase work dosage. So make sure that when you start something, you can finish it and that you allocate the right quantity of work, that you invest enough time to finish it instead of doing it by small chunks, going back and forth between topics. Synchronize people and teams, aggregate and manage buffers, so make sure you have some slack. And then you can also standardize to make repetitive tasks easier and faster, and make a difference between big tasks and small tasks, because often multitasking is caused by interruptions because of small tasks that appear from nowhere. Okay, so this is a list. Sorry, I'm a bit fast on it, but I will give you examples. Examples from companies that were using Agile but wanted to inject some theory of constraints to continue to improve or to be more agile or to complement their initiative and to continue to learn and try new things. I will show you some tools from the theory of constraints, but you can also use traditional agile tools or lean tools to support the agile principles and rules of flow. We will talk about project staggering, portfolio fever charts, critical chain project management plan, and Kanban boards. Here, let's talk about an example from a company that is called NuNet. This is an open source company and an open source case study. If you want to know more, you can Google it and have a look at what they do, where they stand, what is their progress, what tasks they are working on. Well, everything is almost transparent. They are building a decentralized cloud computing platform. You can use it for machine learning, some AI training, decentralized science projects. Well, it's about sharing your computing power with the network of users. And you can share your computer, or you can ask people to share with you their computing power to do whatever you want to do with that. So they are building the platform that enables you to do that. And they are really true agilists. They implement Scrum, and they are open source, so everything is on GitLab. And they wanted to use critical chain because their platform is quite complex. And even if Agile is great to help them know where they stand, synchronize the teams that work remotely, there are many dependencies. And they were a bit stuck, or sometimes they started to work on features and they realized that they were blocked because of dependencies. And still, they didn't want to, to be too rigid, and they didn't want to do waterfall. They wanted to remain really agile and adapt to the new discoveries because it's very innovative. So they wanted flexibility, and critical chain is quite good at that because, as I said, you allow buffers and it's compatible with all the routines from Scrum and Kanban boards, Kanban, visual management that were already used by the Scrum Masters and the teams. So what they did basically is to create a high-level plan, a critical chain plan. So it's a Gantt chart, sorry. But in this Gantt chart, you have high-level work packages which contain chunks of work. So in GitLab, they call it issues. And the issues can be visualized on Kanban boards. It's interesting because it enables to see the groups of issues that have to be done before the others. It helps to understand who has to work on what groups of issues and to prioritize it to minimize multitasking. Because in the past, some experts, they had a lot of issues on their plate and they didn't know what was a priority. And when they started, because they thought it was a priority, they realized that they were waiting for other people's work because of all these complexities and dependencies. Usually what you want to do is to cut this complexity with modules to cut dependencies, but sometimes you have to deal with it and acknowledge these dependencies. And that's where critical chain is great. And still, you don't want too many details, and you still want to be flexible. You still want to have an overview of the flow of work, of the bottlenecks, and Kanban boards are great to do that. So they mixed critical chain and their agile practices in GitLab, and you can see it directly on the GitLab open source website. Okay. On the top, you have their fever chart. So that's how they monitor if the project is on time or not. They try to be on time for releases, but because it's a very innovative project, you can see that the fever chart is quite hectic and goes to the top and then to the bottom. So it's difficult to handle, but you have way more visibility than before with that. So they were quite happy with this, and now they implement it on all their projects. Now I will talk about another project where the company implemented almost all the rules of flow. They use triage to know what projects they need to work on and what projects they want to give to their network of partners. So just to explain, it's an IT company, and they publish and implement complex IT systems, ERPs. So you know that ERP projects are difficult to handle. Many companies have trouble to deploy these complex pieces of software. And their challenge, because of digitization of companies, was to deploy more ERPs in shorter lead times. To do that, they wanted to use critical chain, but their development teams were already using Agile, and the R&D departments are Agile. But because ERP projects are one-off projects, and you have some constraints, they wanted critical chain and serial constraints. So the main challenge was that the consultants and developers were multitasking a lot because of all these customers, all these projects running at the same time, and they could not focus and could not finish what they had started. Then they used to start tasks even without all the requirements, all the understanding of what the client needs, clear understanding of the processes at the client side. And they worked a bit on some processes, then a bit on another process. For example, they worked a bit on supply chain processes to implement some features of the ERP, then a bit on the invoicing processes, etc. So it was confusing. And when you have a lot of projects and many different clients where you're trying to implement the ERP, you get lost. And that's where we use the theory of constraints and critical chain. So the idea was that we start with pilot projects to plan the projects the critical chain way and to see what is required to go faster. And you realize that consultants and developers, they need to spend more time on one project. But to do that, it means that you need at some point to have queues, to have some clients that wait. To do that, so to stagger the projects when you face customers, what you can do is to use full kitting. So ask the customers to prepare inputs so that when the consultants visit the company and when the developers start working on developing the specific features, the specific requests of customers, they have everything ready to start. And so doing so, you take advantage of this waiting time to get the customer do useful things for you. And this is a win-win solution where you can prepare better the projects, focus the teams on less topics, and accelerate. On each and every project, if you want to work better, it's good to have a critical change plan and Kanban boards to enforce relay race. So you want to see when people are blocked. You want to see when there's a problem. You want to surface these problems to have the meaningful discussions required to solve them. And that's where all the agile practices are useful. And so we implemented a Kanban board, but not only for developers, but also for the consultants to show the handoffs, the handovers, and to show the where you need collaboration to solve problems, and when you are ready to start a new feature, working on a new feature, etc. So doing and enforcing all these rules of law with talk tools, link tools, or agile tools and practices, they achieved a record deployment time, and now they target 20 or 30% reduction of lead times to implement the software at their customers. Just a quick overview of what it looks like if I wanted to draw a picture of that. So you have teams, you want flexibility, you want autonomy of the teams. To do that, it's great to use Kanban boards to show the handoffs, to show the waiting items, to show the problems, what is blocked, to show the bottlenecks. So you want Kanban boards for different teams and many projects on the same Kanban board. So many know you want a WIP limit. What you want to visualize is problems and bottlenecks. Then you want to take into account the dependency and uncertainty. That's where critical change plans are very useful. You don't want to overburden the teams. So you need to stagger projects based on resource limits, contentions. To do that, you can use load versus capacity calculations or just WIP limits. It depends on the sophistication or the approach. But the goal is to control the amount of work in the organization. And then you can monitor everything on a fever chart while still being agile because the teams manage their work autonomously with Kanban boards for all the details. And you also make sure that they have everything required before starting an important phase on initiatives with definition of ready, definition of done, and what we call in the theory of constraints, full kitting.